Hi everyone, we're going to run some digested sediment samples on the ICP today. Here's the instrument, and this is the tubing that we're going to use to introduce our sample into the instrument. Our sample will go through this tubing around this peristaltic pump into the nebulizer. This is where the aqueous sample is converted into a mist, and a lot of that sample does go down the drain into a waste beaker, but some of it does go through this transfer tubing, and that mist continues through this tubing, and then it goes to the torch. When we light the plasma, you'll be able to actually see the plasma where your sample gets atomized and electronically excited. So here we are at the instrument software. This shows all of the instrument components. We're going to be using an argon plasma today, so we have our argon gas, it's okay, and it's telling us that the plasma is off and that the pump is off. So maybe we could try to light it, and this will take a few minutes. So we've just lit the plasma. Now you can see on the software that it's telling us that the pump is turning, and we have a message here that the plasma is on. So let's go take a look at the instrument. Can you see the glow of the plasma there? What you're looking at is the emission of argon. Again, this is an argon plasma. So just as a demonstration, I'm going to introduce 10,000 parts per million of yttrium, and we're going to watch what happens when this concentrated yttrium solution reaches that plasma. So just putting the tubing into the yttrium, and maybe I'll increase the pump speed so we don't have to wait so long. Can you see how the pump is spinning faster? And can you see the yttrium? What you're looking at there is the emission of yttrium. It got atomized and excited in the plasma. So now we'll move on to our samples. So before we run our samples, we do have to set up our method, and using this periodic table, I hope you can see that we've already selected iron, copper, and lead. And then we've entered some important conditions. We're going to use a 10-second read time. That is the length of time that the detector is measuring those emitted photons. I don't know if you can see here, but we've already entered our 5 standards and their concentrations. And then that's it for the method development. We've already created a sequence. You can see that we're going to run our standards first, then all of our samples. So we should be able to just press this play button, and now we're prompted to present blank and press OK. So I'm going to come over to the instrument, and now I'm just going to move our tubing from our rinse DI water, and I'm putting it into our blank, which is 1% by volume nitric acid. And you can see here that the instrument is getting tired of waiting, so I'll press OK, and now it's happy. So now, a minute later or so, we have another message, present standard 1, and press OK. So I'm going to go over to the instrument. I'm going to give this tubing just a little rinse in that DI water while I get my standard. And I'm not going fast enough. So here is standard 1. And I'll go back to the software and I'll just click OK. So we've been running samples for quite some time, and I think we're getting some good results. Look at that nice linear calibration curve for copper, great R squared, And all of the R-squareds for these standards looked really nice. So all we have to do now is just finish running our samples, export the data into Excel, and that'll be it. Thanks a lot.